4.4, Pascal's triangle. What we're going to do is just look at this triangle and see if you can spot the pattern. How are these numbers generated to form this pattern? What is special about this? So take a moment to see if you would be able to write out the next line. A hint is that these three numbers are related. So, do you have it? Let's take a look at the definition of what Pascal's triangle is. Now, Blaise Pascal created this as a young lad, but didn't quite understand all of the consequences that came about. This pattern is as follows. Pattern 1, Pascal's method. Each term in Pascal's triangle is equal to the sum of the two adjacent terms in the row immediately above. So it starts off with 1, 1, 1. But then from each following line, what we do is we take 1 and 1 and add it to make that next term 2. Similarly, 1 and 2 add to make 3. And continue on and on. So if TNR is the term in the row n, position r, then TNR is equal to Tn minus 1, r minus 1 plus Tn minus 1, r. Now this is an algebraic representation of adding the terms before. And these correspond to this right here. This is an index of Pascal's triangle, which helps us navigate it for many applications we will learn in the future, as well as in this lesson. So, one thing to address is that it starts off with row 0. So this first term is 0, 0, meaning row 0, term or entry 0, starting from the left-hand side, moving to the right for the second input. So this would be row 1, column 0. And this right here is row 5, column 3, because it's 0, 1, 2, 3 elements into this row. Now, what we're going to look at is the following, just representing the terms here and their relationship. This is 5 plus 10 is equal to 15. So this term is in the 6th row, 0, 1, 2, 3, 4, 5, 6. I like to use this column. Yes, it is at an angle, but to know which row I'm in, because that corresponds to, if this is 0 and this is row 1, this first row tells us which row we are in. So this is 6, 2. And secondly, the column 0, 1, 2. This is in column 2. So this term, so row 6, column 2 corresponds to the 15. And 5, 1, that's down 0, 1, 2, 3, 4, 5. And term 1 is 0, 1, 5. Similarly, row 5, column 2 is 0, 1, 2. So this is the index representation of these numbers. 5 plus 10 is 15, generating that number. So we'll see how this is helpful to us in the future, but know that this is how you navigate Pascal's triangle. Let's take a look at some of the features that appear, or patterns that appear in Pascal's triangle. Row sums. So sums means sum is means to add things together. So 1 is 1, 1 plus 1 is 2, 1, 2, 1 is 4, 8, and so on. What would we expect is that next row? Can you spot the pattern? So it looks like the terms are doubling from one page to the next. One page, one line to the next. So therefore, we could express this as 2 to the power n. And that next term would be 256. So n is the row, and 2 to the n gives you the sum of the entries in each of these rows. So that being said, that's one pattern. Pattern number 3, Triangular numbers are numbers that form a triangular array. Now, that means that if you were to draw the shape of a triangle, this would work with this number of items. So the pattern is 1, 3, 6, 10. And what we're going to learn about in this course is a special type of relationship between numbers called recursion, meaning that it's based on the previous step. Notice the color coding of each of these different triangles. 1 is represented here in this triangle, and then we added 2. Then this right here is like the previous step. This is that recursive nature that I was referring to. Then we add an additional 3 items. And that makes a triangle shape, and we can say that that is 6. And then we add the previous step. We're going to add 4. So therefore, that ends up being 10 in total. And notice that this is 1, 1 plus 2, 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4. It's the sum of consecutive numbers, something that we haven't seen in previous types of relationships with numbers. We've seen linear relationships, quadratic relationships, and exponential relationships describing different types of patterns, but nothing yet that is talking about recursion. So, that being said, we can find these numbers, 1, 3, 6, 10, within Pascal's triangle. If we look at column 0, which is representing the ones, nothing interesting, just 1. Counting numbers, 1, 2, 3, 4, 5, 6, 7. This is where it gets interesting, the second row, because row 0, row 1, row 2, these are triangular numbers. 1, 3, 6, 10, and this pattern continues. So that's helpful to know that that is occurring in this column. Similarly, the pattern exists going the other way in the other diagonal because the symmetrical nature of this triangle. But this is going to be a helpful resource to us, and we're going to learn a lot of these applications through our practice questions. So many more patterns exist. We'll investigate in the practice problems. Pascal's triangle has many applications in probability theory, which we'll learn later in this course.